Hi everyone, welcome back. So this is a third video we are posting on the concept of our data types. So in the previous videos we have discussed what are data types and all the other key points regarding the data types. We have covered the primitive data types completely in those videos. So in this we are going to be focusing on the concept of memory allocation. So how much of memory is going to be allocated for each and every type of data that I'm planning to store inside, and what will happen when I go beyond the specified range. So these are the two topics what we are going to be discussing in this particular video. Right. So first, data types. We know that each and every data type occupies some specific amount of memory in my system. So how much of memory is going to get allocated for the data types? So how exactly to find this option? How exactly to know the correct detail regarding this? So for that, I will be making use of one operator which is called as size of. So size of is an operator which is available for us in the C language. And what is the purpose of this operator is this operator finds out the total number of bytes that is going to get allocated for a particular data type. So that is how this particular operator is going to be working. Now, let us find out first for the integers. Now, we already know that integers means whole numbers. And what are the different types of integers we can create? Remember, in the previous video, we have discussed a lot about all these signed and unsigned integers. Then int with my modifiers as short int, long int. So here we are going to find the amount of memory that is going to be declared or that is going to be allocated for each and every integer data types. So for that, just have a look here. So how am I going to make use of this size of operator? Just see. So size of, inside that, I have to mention the data type name. Whichever data type I want the value to be found out. That data type just mention inside the size of parenthesis. So this will return an integer value. Okay, so that is why I'm using percentage %d to print my result. So what is this going to tell me? What is this integer number represents? Is nothing but the number of bytes that is going to get allocated. Look here, I already told you one thing. When it comes to int, when it comes to the int data type, the allocation of your memory depends on our system. So based on the system configuration, you may get the output either as 2 bytes or as 4 bytes. My system, the laptop which I am using to prepare this demo, it is a 64-bit machine. So in my laptop, integer occupies 4 bytes. So based on the system configuration, your output may differ. And this is only for our integers. Right. So when I execute this, see here, I'm using all the formats of integers. So I'm using signed int, then I'm using unsigned int, short int, then unsigned short int. I'm using long int, unsigned long int. So I'm using all the integer categories. So when I execute, as I said, based on the system's configuration, your output will be something like this. So when it is integer, whether it is a signed int or an unsigned int, it is going to get allocated only 4 bytes. Remember, but the range differs because signed int means it can accept both positive and negative number. Remember, in the previous video, I told you the formula of how we can calculate the range. Same way, unsigned int also occupies only 4 bytes of data. Again, the minimum and the maximum value what you can store is different because unsigned int, it accepts only positive numbers. Same way, short int, 2 bytes. So long int, 8 bytes. So this is the memory that is going to get allocated for integer data types. Right. So next category, of course, we have the real numbers. Okay, we have the real numbers, and the real numbers, remember, float, double, and long double. So long double, along with the modifier, we are going to make use of. So these data types, they have a fixed memory. It does not change along with the system. It is going to have a fixed memory. So when I execute, what is it going to be? Float will occupy 4 bytes, double will occupy 8 bytes, and long double will be occupying 16 bytes of memory. Remember, all these are bytes, not bits. The size of operator always returns the number of bytes that is going to get allocated. Right. And then, of course, we have the char. So the char data type, single character, that is going to occupy 1 byte. And for void, I have a data type called as void. So the void data type also occupies 1 byte of memory. Right. So let us try to execute this program. So what I'm going to do, I'm just going to copy this piece of code. In the presentation, I showed you everything separately. Here, what I have done, I have just put everything inside a single category. Integers is also there, real numbers is also there, character, void, everything I have put under one single demo here. So that is the only difference. Other than that, it is the same program. Look at the output, what I'm getting. So for each and every data type, so how much of memory is going to get allocated, I can get to know that using this size of. Now, in this, we did not see for the string values. Right, in this, I have all the integer types. I have all the real numbers. I have a single character. I have the void. All the fundamental data types along with this modifiers is covered. But what about strings? So let us see one small example for that also. So remember what I said, strings we don't have a separate data type called a string. We use the char data type only to create the string values also. So first I'm going to create a variable like this. So let us say char, I am saying a of 50. So what do you mean by this? This particular variable a can hold up to 50 characters. So now when I want to know how much of memory is going to get allocated for this. So remember, for char, it is giving me 1 byte. That means I am storing 50 characters. Up how much bytes? 50 bytes of memory will get allocated. 1 byte for each and every character. That means I am saying maximum of 50 characters. So it is going to allocate 50 bytes of memory. So let us check that out. Okay, we don't have to assume. Let us cross check it. So I'm just going to say printf. Okay, first give a message. So I'm just saying memory of the variable a is equal to, so percentage d. Now after the comma, size of the operator, inside that I am going to mention the name of my variable, and of course terminated with a semicolon. Run this piece of code. See what it says, 50 bytes. Suppose let us change the size. I am saying now the size is only 10. Now you run this code. So it is going to occupy only 10 bytes of memory. So depending on the number of characters you're planning to store inside the memory, that much it is going to get allocated. So remember, that is not going to change. Each character will have the capacity of only 1 byte. So then based on how many characters, that much of bytes will be allocated. So this is how it is going to happen for the string values. Right. So this is the basic concept of our memory. How to find out what will be the memory capacity of my data types. Right. So now there is one thing which I already told you. Range. Minimum and maximum value that can be stored within my particular variable. So what is the minimum and maximum capacity it can store? So this we can find out using the formula. We already discussed. I can find out using the formula. And if you want, you can remember. It's all predefined for us. You can remember the numbers also, but all these are tedious works. So instead of that, we have 2 header files available for us. Okay, 2 header files are there. One header file is called as limits.h, and the other header file what I have is float.h. So these are the 2 header files that I have, and these header files have the range predefinedly available inside. What is the range of each and every data type? They have already created it. It is available for us inside this header file. So if required, we can also make use of this header file to know the range of values. Right, limits.h is for the integer data types. That is your short int, long int, normal int, unsigned, signed, all these, anything related to integers, and also your char data type. So anything related to integer and char. Remember in the previous video I told you, char and integers have a very special bond. Even though we are giving it as a character, internally my compiler is going to treat it as an integer based on the ASCII value. Right, so for all type of integers and char, we can use the header file limits.h. So this will give me the maximum and minimum value that the data type can hold. And for all our real numbers, float, double, long double, for all our real numbers, I have another header file available for us that is called as float.h. So I can make use of that header file also to get my work done. Okay, so yes, these header files are very useful. Why? It is really very difficult for us to remember the number, and as well as if you want to do the calculation. If I want to do the calculation also, it's a little bit of a tedious job. So instead of that, by making use of these header files, they have something what we call as a predefined constants. Okay, everything, the minimum value and maximum value are created and stored inside constants. So simply we have to make use of it and print the value, we will be able to get it. So these are the two header files which will help us to know the range of the data types. Right, next important question is, what happens when we go beyond the range? See, I am saying this is the capacity. This is the minimum value. This is the maximum value. So this is the capacity. So what will happen if I go beyond the capacity? How is my compiler going to react at that time? So for that, let us try to understand this with some simple examples. Now, first have a look at this program. So I am here creating a char data type, char variable. So I'm saying unsigned char C is equal to 255. Okay, then I'm saying C is equal to C plus 10. And then I am printing the value of C. The program looks very, very simple. It is not any big calculations or something. I am just having a value 255. With that, I am adding 10 and I'm just going to print it. So normally what will we think? Okay, so output is going to be 265. But when you actually execute the program, so what am I going to do? I'm going to execute the program. So let me just copy this piece of code. Okay, and there you go. I'm going to run this piece of code. Look at what is the output that you're going to be getting. So definitely it is not 265. Okay, so the output, what we are going to be getting for this is something like, there you go, 9. Now, why is this giving me the value as 9? How is 9 related to any of this concept? So that is the what you have to understand. This is what I said. When we go beyond the range of a specific capacity of the data type, my compiler is going to do something in the background. So output of this program is going to be 9. So now what we have to know is how we got this 9. So for that, what we are going to do, first you have to know what is the range. Unsigned means what? Only positive numbers. So what is the range? Char data type occupies 1 byte. So 1 byte means range is 0 to 255. The minimum value is 0. Maximum value that you can store inside is 255. So I am saying C is equal to 255. Statement is valid. No problem. Because yes, that is an accepted value. Now, when I say C is equal to C plus 10, what am I meaning by that? 255 plus 10. So that is 265. So when it is 265, it is going beyond the capacity. Because what is the maximum capacity here? Only 255. So when it is going beyond the capacity, what is my compiler going to do? So the compiler is going to apply a modulo operation. So the compiler is going to apply a modulo operation. So whatever is the result. So here in our case, my result is 265. So whatever is the result, modulo 2 to the power n. This is the background formula my compiler is going to use. whatever is the result of the operation, that modulo 2 to the power n. We already know what is a modulo operator. Modulo operator is it is going to perform the division, and as a result, it is going to give me the remainder value. Normally, division when we do, we get the quotient. But when we do the division using the modulo operator, we are going to be getting the remainder as the result. Now, what is this n? N is number of bits that is getting allocated for the data type. Remember, number of bits. So here I am saying char data type occupies 1 byte. So 1 byte means it is 8 bits. So 265, which is my result, modulo 2 to the power 8. So 2 to the power 8 is 256. So 265 modulo 256, the output you're going to get is 9, and that is nothing but the output that is getting printed for us also. So please remember this, whenever you go beyond the capacity of that particular data type, how is my compiler going to handle the result? Whatever is the result we are going to be getting after the calculation, that result modulo 2 to the power n, where n is nothing but the number of bits that is going to get allocated. Now, let us try to see one more small example to understand this. Okay, have a look here. I am saying unsigned int I is equal to, this is the value I am fixing. So again, unsigned means what? Accept only positive numbers. So I have a capacity 0 to some range is there. So I am saying I is equal to, this is the value. Right, now I am saying I is equal to I plus 20. And then I am printing the value of I. So what is going to happen in this scenario? So let us try to execute the program here also. Okay, so what we are going to do, I'm going to copy the code and I'm going to just run the program here. So what is going to happen here is again something similar to what we saw in the previous code. So here I am going beyond the capacity of my integer data type. My integer data type, it can have maximum of only this much. But now I am going beyond that value. See what is the output I am getting? 19. Why is it giving me the value as 19? So just have a look here. So now, as I already told you, my system is a 64-bit system. So integer occupies 4 bytes. So 4 bytes means 32 bits. Right, so 2 to the power 32. What is the capacity? 0 to, this is the value that my integer can actually store. Okay, this is the capacity of my integer. Now, when I am saying I is equal to so-and-so number, this is valid because it is coming within the capacity. It is coming within the capacity, so statement is valid. Now, when I add 20 to this, then it goes beyond the range. Then it goes beyond the capacity. So again, when I go beyond the capacity, what is the formula I said? So whatever is the result, modulo 2 to the power n. Just apply the same formula. This is the result you are going to be getting. So this is what happens whenever we try to store a value which is more than the capacity that data type can actually accept. Okay, so these are all the important points we have to know whenever we are working with the concept of our data types. Right, I hope you have understood. We'll see you in the next video. Thank you.